Good evening, my YouTube viewers. In this video, what we're going to talk about is a long short-term memory, which is a neural network that we are going to use to carry out time series forecasting. So a long short-term memory is a type of recurrent neural network designed to handle long-term dependencies in sequential data. So we're going to write a computer program in Python to create a LSTM to forecast a time series data. So in order to do that, the first thing that we have to do is we have to import some libraries so that whenever we execute the program, it will run. So the first thing we're going to do is we're going to import NumPy as NP, which is the numerical library that also creates NumPy arrays. We're then going to import matplotlib.pyplot as PLT, and that's a visualization library. And so from sklearn.preprocessing, we're going to import min-max-scaler. So sklearn is Python's machine learning library, and min-max-scaler scales the data from 0 to 1. And the reason why it scales the data from 0 to 1 is because the data is able to train better if it isn't closely dimensioned. Then we're going to, from tensorflow.keras.models, we're going to import sequential, which means we're going to be using a sequential model. So TensorFlow is the deep learning library of Python. Keras is a section, a module in TensorFlow that allows people to make deep learning models easier. And models is the model that you're going to create. And sequential is a sequential model. You've got two types of models. One type of model is sequential, and then they have another type of model. But normally we use sequential models, and in this instance we're going to use sequential models. And then from tensorflow.keras.layers, we're going to import LSTM and dense. And LSTM and dense are two layers that we're going to actually put in the neural network that we're going to create. So we're going to generate synthetic time series data, and this is going to be monthly energy consumption. So the first thing that we want to do is we want to set our seed. So we're going to set the seed in order to make sure that every time you run the program, the initial values will be the same. So you do that by typing in np.random.seed, and you can type in any number you want in the brackets. So time steps equals np.arrange brackets 100. So you've got a NumPy array of 100 steps. So series equals 10 plus 0.1 times time steps plus 5 times np.sign bracket 0.2 times time steps plus np.random.normal. Normal means it's a normal distribution, bracket 0, 0.5, len time steps. So the length of time steps is going to be 100. And then we're going to normalize the data. So scalar equals min-max-scaler brackets feature range equals 0 to 1. So all the data is going to be scaled from 0 to 1. And the reason why that is because data trains better if it's closely dimensioned. And if it's from 0 to 1, it's going to be closely dimensioned. So you have scaled series equals scalar.fitTransform bracket series.reshape -1, 1. And then so basically you have to reshape the data to -1, 1 because we're dealing with sklearn, and sklearn wants the data reshaped like that. So now we're going to prepare the data for the LSTM. So we're going to define the function def create sequences brackets data, comma, sequence length. And that's what you're going to, the arguments that it's going to accept into the function. So x and y are two empty lists. For I in range len data, comma, sequence length. No, so for I in range len data, brackets, len data minus sequence length, colon, x dot append bracket data square brackets I colon I plus sequence length square brackets y dot append brackets data square brackets I plus sequence length square brackets and then you're going to return NP array X and NP array Y. So you're going to return a NumPy array which is composed of all of the X appended data, and you're going to return an NP array that's going to have all of the Y appended data. And it's going to have 100 because if the time steps are 100, I think it's going to be 100. So sequence length equals 10. So sequence length is going to be one of the variables or one of the arguments that the function is going to accept. X comma y equals create sequences. That's your function that you just made. Brackets scaled series, comma, sequence length. So you've got your scaled series that you have previously made, and your sequence length, which is 10. So we're going to split the data up into training and testing sets. Train size equals int len x times 0.8. So your training set is going to be 80%, and your testing set is going to be 20%. X train, comma, x test equals x square brackets colon train size square brackets comma x train square brackets train size colon square brackets, and y train comma y test equals y square brackets colon train size square brackets comma y square brackets train size colon square brackets. And then so now what we're going to do is we're going to build our LSTM. So model equals sequential brackets model dot add brackets LSTM brackets 50 comma activation equals reglue. Reglue is a very common activation model. Comma input shape equals sequence length comma 1 brackets model dot add dense brackets 1. Now we're going to compile it. Model dot compile brackets optimizer equals Atom. Atom is also a very popular optimizer. Brackets loss equals mean squared error. So that means you're going to measure the loss at mean squared error. Now we're going to train the model dot fit brackets x train comma y train comma epochs equals 20 comma batch size equals 16 comma verbose equals 1. So that means it's going to train it for 20 epochs, and an epochs is 20 iterations of iterations. So if you've got 100, so it's going to be 20 times 100. And then the batch size is 16, and verbose means that you're going to be able to see the work. Now what we're going to do is we're going to make predictions. ypred equals model.predict x test. ypred rescaled equals scalar.inverse transform ypred. So what you're doing is you're reversing the scaling that you had previously done early in the program. Y-test rescaled equals scalar.inverse transform Y-test. Now we're going to plot the results on a graph. PLT dot figure brackets fig size equals 6,4 brackets. PLT dot plot brackets time steps square brackets negative ln y test colon square bracket comma scalar dot inverse transform brackets y test dot reshape brackets -1, 1 brackets comma label equals true values comma color equals blue. PLT dot plot brackets time steps square brackets negative ln brackets y test colon square brackets comma y pred rescaled comma label equals predictions comma color equals orange comma line style equals dash. The title is LSTM time series forecasting. X label is time steps. Y label is value. You get a legend, and we're going a grid, and we're going to print it. So you can see here we had 20 epochs. And so because verbose was set to 1, you can actually see the work. If you didn't want to see the work, then you would set verbose to 0. But it did go through 20 epochs. And then, so now you can see your LSTM time series forecasting. So the true values are in blue. They're the values that we created. And the predictions are in orange. And you can see that the predictions are actually less than the true values. But that is just one way that you can perform time series forecasting where you don't use the stats models. You use TensorFlow instead of stats models. So this is just another way to perform time series forecasting, and you'll have to experiment with it to try to get the best possible outcome. So that concludes this video. The next video, we're going to be talking about gradient boosted trees for time series, and I hope that you decide to watch it.